Water is a physiological necessity for all life and is from the ecological viewpoint chiefly a limiting factor in a number of habitats such as land environments, water environments where the amount of water can fluctuate greatly, or where high salinity fosters water loss from organisms by osmosis. We are going to discuss number 1, rainfall, number 2, humidity, number 2, evaporating power of the air, number 4, the available supply of water surface, and number 5, dew in the following slides. Each of these aspects of water will be briefly described here. First of all, I will describe the distribution of Earth's water. Water covers 71% of the Earth's surface. It is estimated that 96.5% of water is in seas and oceans, 1.7% is groundwater, and 1.7% is fixed in glaciers and ice caps in the Arctic and Antarctic circles. A large proportion of water exists in water bodies and a much smaller fraction is suspended in the air as vapors, clouds, etc., which falls as precipitation. Thus, only 2.5% of the Earth's water is fresh water, and 98.8% of this is held as ice and groundwater. Less than 0.3% of fresh water is contained in rivers, lakes, and the atmosphere, while an even lower amount is in biological bodies and is in the manufactured products. So this slide again, it shows the water resources of Earth. This is a graphical distribution of the location of water on Earth. So we can see that 97% of water is oceans, only 3% is fresh water. Now, if we observe the fresh water, this 3% that is fresh water, among this 3%, about 70% or 68.7% is ice caps and glaciers, and the remaining 30% is groundwater, and a very small amount, 0.9%, includes other water sources. Now let's observe this other water sources, 0.9%. In this 0.9%, 87% is lakes, 11% is swamps, and 2% is rivers. Now, how water acts as a limiting factor for humanity? First of all, water is necessary for drinking purposes. When it comes to drinking, safe drinking water is a necessity for humans as well as other organisms, although it does not contain any calories or organic nutrients. Globally, the availability of safe drinking water has improved in the last few decades. By safe drinking water, we mean saaf pani, clean water. However, approximately 1 billion people still do not have access to safe drinking water, while another 2.5 billion do not have adequate sanitation. There is a clear correlation between access to safe water and GDP per capita expenditure incurred on goods and services, including compensation of employees. इसका मतलब ये है कि जिन ममालिक में सेफ वाटर अवेलेबल है वहां पे जीडीपी ज्यादा होगा और वहां पे जीडीपी लोगों की भलाई के लिए यूज होगा. However, it is estimated that by 2025, over half the world's population will be vulnerable to water shortages. यानी जो वक्त गुजरेगा 2025 तक, 5 साल के बाद तकरीबन दुनिया की जो आधी पॉपुलेशन है, it will face water shortages. Yeah. For instance, in Pakistan also, in the big cities such as Karachi, Islamabad, Lahore, हम ये बात देख सकते हैं कि वाटर शॉर्टेजेस दे आर अकरिंग इन सिटीज. लोगों को पानी की अवेलेबिलिटी नहीं है, इज नॉट वाटर इज नॉट अवेलेबल और देयर इज शॉर्टेज ऑफ वाटर इन सिटीज. तो सेफ ड्रिंकिंग वाटर के बाद अब हम यही शॉर्टेज ऑफ वाटर की बात करेंगे, स्केर्सिटी ऑफ वाटर की बात करेंगे. Water is becoming scarcer as the human population continues to grow and demand high quality water for domestic purposes and economic activities. तो जो इंसानी आबादी बढ़ रही है तो उसकी जो डिमांड है फॉर हाई क्वालिटी वाटर फॉर डोमेस्टिक एंड इकोनॉमिक एक्टिविटीज वो भी बढ़ रही है. डिमांड इज ऑल्सो इंक्रीजिंग. It is estimated that around 70% of fresh water is used in agriculture. Precipitation has become unpredictable due to climate change. तो हम देख सकते हैं कि ये जो वाटर है, फ्रेश वाटर है, इसका 70% एग्रीकल्चर में यूज हो जाता है. तो जब एग्रीकल्चर एक ऐसी एक्टिविटी है विच इज वाटर स्ट्रेनुअस, वाटर एग्जॉस्टिव, यानी जिसमें बहुत ज्यादा पानी इस्तेमाल होता है. इसके अलावा हम ये भी बात जानते हैं कि प्रेसिपिटेशन ऑल्सो सपोर्ट्स एग्रीकल्चर इन ए नंबर ऑफ एरिड रीजन्स. लेकिन प्रेसिपिटेशन भी वक्त के साथ इट इज बिकमिंग अनप्रिडिक्टेबल ड्यू टू द करंट climate change. Water quality is also important for human health as well as the quantity and quality of grain crops. It has an effect on soils, crops and environment. तो वाटर की जो क्वालिटी है वो ना सिर्फ इंसान की सेहत के लिए इम्पोर्टेंट है बल्कि एक साफ पानी एग्रीकल्चर के लिए भी, ग्रेन क्रॉप्स के लिए उतना ही जरूरी है. अगर पानी कॉन्टेमिनेटेड होगा तो हमारी जो क्रॉप्स हैं वो भी कॉन्टेमिनेटेड होंगी. अब हम वाटर कंटामिनेशन की बात करेंगे, वाटर पोल्यूशन की बात करेंगे. वाटर पोल्यूशन इज द कंटामिनेशन ऑफ वाटर बॉडीज यूजुअली एज ए रिजल्ट ऑफ ह्यूमन एक्टिविटीज. वाटर बॉडीज इंक्लूड फॉर एग्जांपल लेक्स, रिवर्स, ओशियंस, एक्विफर्स एंड ग्राउंड वाटर. Water pollution results when contaminants are introduced into the natural environment. Some uses of water, example domestic purpose, agricultural production, industrial production, mining, power generation and forestry practices cause deterioration in water quality and quantity. यानी जो some of the anthropogenic activities, some of the human activities, for example, domestic purposes, when we use water in our houses, so when we wash clothes, now the water, it has become contaminated with surf and detergents, and we will this runoff from cities will contaminate the water body. Our sewage, when we flush in the toilets, when we flush the toilets, so again we are contaminating the water. Agriculture production की अगर हम बात करें तो when we use fertilizers on our crops and the fertilizer runoff from the crops into the nearby water bodies will again contaminate the water. Similarly, when we use pesticides on our agricultural crops, the pesticide runoff into the nearby water bodies will contaminate those water bodies. Industrial production. Similarly, when we use water in the industry and the industrial runoff, the effluents from the industry, they also contaminate the nearby water body. So all these activities, they cause deterioration in water quality as well as quantity. This impacts the aquatic ecosystem and also access to safe drinking water for human consumption. Water quality and quantity are thus linked together. Now, this picture, it shows water pollution. Now we will discuss rainfall. Up till now, we have discussed how water is important for life and what are the major issues that are faced by humanity in this millennium. Now we are going to discuss various aspects of water that are important for all living organisms. The first aspect is rainfall. The quantity of water expressed in inches precipitated as rain, snow, hail, or sleet in a specified area in time interval is known as rainfall or precipitation. Rain is a major component of the water cycle and is responsible for depositing most of the fresh water on the earth. It provides suitable conditions for many types of ecosystems as well as water for hydroelectric power plants and crop irrigation. Number 1. Types of precipitation. So these are the following types. The first type is rain. The second type is snow, sleet, freezing rain, hail. So in this figure, I have shown the various types of precipitation. First of all, what is rain? Rain is simply liquid falling from the sky. What is snow? Snow falls when water vapor condenses as ice crystals. The air temperature is below freezing all the way to the ground, so the ice crystals remain frozen. They fall as flakes, so these are the snowflakes. Second type is sleet. Sleet forms when snow melts as it falls through a layer of warm air and then refreezes. It turns into small clear ice pellets as it passes through a cold layer near the ground. So here we can see the snowflakes. They first melt due to a warm shallow layer of air. Then again there is a cold layer which makes them refreezes. Now, what is freezing rain? Freezing rain falls as liquid water. It freezes on contact with the cold surfaces near the ground. It may cover everything with a glaze of ice. If the ice is thick, its weight may break tree branches and pull down power lines. So, when the rain it falls, it is liquid. However, when it comes in contact with the ground, it becomes a layer of ice. Okay, hail. Hail forms when strong updrafts carry rain high into the troposphere. So, rain is carried high into the troposphere. The rain freezes into balls of ice called hailstones. This may happen over and over again until the hailstones are as big as baseballs. So hailstones can be quite big in size. Hail forms only in cumulonimbus clouds, that is the thunderstorm clouds. So after the types of rain, we will describe rain shadow. Rainfall is determined largely by geography and by the pattern of large air movements or weather system. As anyone who accesses weather reports knows, weather systems within the United States, they move mainly from west to east. In general, the higher the mountains, the greater the effect. As the air continues beyond the mountains, some moisture is picked up and rainfall may again increase somewhat. Thus, deserts are usually found behind high mountain ranges. So, we can see here that as we move from the sea, as the air moves from the sea, first of all, at the sea, at the water body, water will evaporate. This, the air will carry these water vapors and warm, moist air rises up the mountain. So this is the mountain. As it will rise up, water vapor cools and condenses to form clouds. Precipitation from these clouds will then fall on the windward side of the mountain. So this is the windward side and precipitation will fall here. So when the air is devoid of all its water vapor, then it will move forward. Now the air mass is dry with no water vapor, and therefore the dry air will descend, and this part of the mountain, the leeward side, would be a desert. So this is the rain shadow effect. Okay, this is a satellite image. It shows Pakistan. This is the Gilgit-Baltistan region of Pakistan. This is the Indian occupied Kashmir. This is India, and this is the Himalayan region. So we can see that beyond the Himalayas, behind the Himalayas, two very big deserts are present. The Taklamakan Desert and the Gobi Desert. So here again we can see this is the Taklamakan Desert and this is the Gobi Desert, and this is all Himalaya, the Himalayan mountains. You can also observe the snow cover. So the annual distribution of rainfall is also important. Distribution of rainfall over the year is very important limiting factor for organisms. Most parts of the world experience an uneven annual distribution of rainfall. However, Earth has locations where there is minimal seasonality due to an even distribution of temperature and rainfall. An example of a location in such an environment is the city of Andagoya, Colombia, South America. So what we are talking about is that एक annual distribution rainfall की बहुत ज़रूरी है, यानी कि ये annual distribution जो है ये even भी हो सकती है और ये uneven भी हो सकती है. तो यहाँ पे हमने आखिर में एक एग्जाम्पल कोट की है एक ऐसी जगह की जहाँ पे एक इवन रेनफॉल डिस्ट्रीब्यूशन है, टेम्परेचर्स भी ऑलमोस्ट इवन है. तो ये एक ऐसी लोकेशन है ज़मीन पे, हमारे प्लैनेट अर्थ पे ऐसी लोकेशंस मौजूद हैं जहाँ पे टेम्परेचर और रेनफॉल की इवन डिस्ट्रीब्यूशन की वजह से सीजनैलिटी मिनिमल है, यानी कि जो 4 सीजन्स हैं, 4 सीजन्स हैं, आप उनको ऑब्जर्व नहीं कर सकते. आप इवन 2 सीजन समर और विंटर को भी ऑब्जर्व नहीं करेंगे. समर और विंटर में भी इतना फर्क नहीं होगा क्योंकि टेम्परेचर इवन है, रेनफॉल इवन है. तो हमने अभी एंडागोया का जिक्र किया. अभी हम यहाँ पे देखते हैं दिस फिगर शोज अनइवन एनुअल प्रेसिपिटेशन. आप देख सकते हैं स्टार्टिंग फ्रॉम जनवरी टू दिसंबर वी कैन सी that during the first 4 months precipitation is minimal, then during the rest of the months, precipitation it increases, rainfall it increases. So this figure, it shows uneven annual precipitation. Similarly, we can also see that the temperatures, they are also uneven. And this is the case of Calcutta, India. Now here we can see an even annual precipitation. This is the case of Andagoya, Colombia. So you can see the temperatures are also almost even throughout the year, and the temperatures are also even and the precipitation is also even. So यहाँ पे इस जगह पे एंदागोया कोलंबिया में हम देख सकते हैं कि टेम्परेचर्स, प्रेसिपिटेशन जब इवन होगी तो सीजन्स नहीं होंगे, कोई डिस्टिंक्ट सीजन्स नहीं होंगे. हाउएवर यहाँ पे प्रेसिपिटेशन और टेम्परेचर की वजह से क्लाइमेट समर का और विंटर का मुख्तलिफ होगा. The situation provided by a 35-inch rainfall evenly distributed over time is quite different, is entirely different from that provided by 35 inches of rainfall that falls largely during a restricted part of the year. यानी rainfall का amount उतना है 35 inch, लेकिन if it is evenly distributed तो इसका जो ecosystem पे effect होगा वो different होगा from that if it is unevenly distributed. Now this is figure number 8. There are two parts. The first part, the top figure shows data for July 2013 and the bottom figure shows data for January 2013. So we can see that vegetation in the northern hemisphere during July 2013 is different from January 2013. So in July 2013, the green color indicates leafy vegetation and dark green reflects highest coverage of plants. However, the brown color reflects desert or minimal vegetation. So we can see that how uneven distribution of precipitation, uneven rainfall can change the ecosystem from green to desert-like conditions during the same year but in different parts. ये जो uneven distribution है rainfall की, it leads to distinctive wet and dry seasons. When rainfall generally tends to be unevenly distributed over the seasons in the tropics, for example, or the subtropics, it often results in well-defined wet and dry seasons. In the tropics, this seasonal rhythm of moisture regulates the seasonal activities, especially reproduction of organisms, much as the seasonal rhythm of temperature and light regulates organisms living in the temperate zones. तो हम यहाँ पे देख सकते हैं कि tropical wet or dry seasons में this slide it shows that rainy in summer, it's rainy in summer, it's dry in winter. Temperatures, they are cooler during the dry season, warmer during the wet season. So the location is tropical. The vegetation region or the ecosystem type is savanna or tropical grassland. So again, this picture shows the well-defined dry season. This picture shows the well-defined wet season. So we can see that how rainfall, it exerts its influence on any ecosystem. So this is the Africa's dry and the rainy season. The dry season greatly increases drought occurrence. Drought can be defined as a prolonged period of abnormally low rainfall leading to a shortage of water. Droughts are common in such ecosystems as the African savanna. In such cases, plants and animals must be able to survive long droughts and also sudden floods. These periods are characterized by low humidity with watering holes and rivers drying up. Because of the lack of these watering holes, many grazing animals are forced to migrate due to the lack of water in search of more fertile lands. Examples of such animals are zebras, elephants, and wildebeest. Because of the lack of water in the plants, bushfires are also common. So we can see the drought-driven wildebeest migrations in East Africa. Now we will discuss annual rainfall distribution in Pakistan. Most of the Pakistan is arid. However, the northern humid belt exists in the foothills of Himalayas. Now we can see that this is the Arabian Sea. As the moisture-laden winds blow towards Pakistan, we see that the southern parts of Pakistan, including the Sindh province, the Balochistan province, and the Punjab province, they are all arid. However, as the rain falls, as the wind, moisture-laden wind, moisture-carrying wind, it ascends the Himalayas. So we see that this moisture is deposited in the form of rainfall or precipitation. And this is known as the northern humid belt, where there is maximum rainfall. And therefore, these regions, they are characterized by forests, dense forests. We haven't shown the data for Jammu and Kashmir as it is considered the disputed territory. So we have only shown the data for Pakistani Azad Kashmir and Gilgit-Baltistan. Okay, now we will discuss major biomes of the world and rainfall. The following tabulation gives a rough approximation of the climate's biotic communities that may be expected with different annual amounts of rainfall evenly distributed in temperate latitudes. So if the rainfall is 0 to 10 inches per year, then the community that can be expected is desert. If the rainfall is 10 to 30 inches per year, then the ecosystem would be grassland or savanna. If the rainfall is between 30 to 50 inches, then the ecosystem would be a dry forest. If the rainfall is more than 50 inches per year, then the ecosystem type would be a wet forest. So this figure also shows rainfall for a number of biomes. In desert, rainfall is about 10 inches per annum. For grassland, it is about 30 inches. For rainforest, it can be as much as about 90 inches per year. For the boreal forests, also known as teja, the rainfall is about 30 inches. For temperate deciduous forests, it is about 60 inches. And for tundra ecosystem, just like the desert ecosystem, the rainfall is about 10 inches. So this is a comparison of biomes with respect to rainfall. Again, this shows different ecosystems with their annual precipitation. So as we are talking about rainfall, we will also discuss acid rain. Acid rain or acid deposition is a broad term that includes any form of precipitation with acidic components such as sulfuric or nitric acid that fall to the ground from the atmosphere in wet or dry forms. So this is a simple definition of acid rain. Acid rain को हम discuss यहाँ पे क्यों कर रहे हैं? क्योंकि we are talking about rainfall as a limiting factor. How rainfall limits living organisms, how rainfall it shapes ecosystems. यानी अभी हमने बात की कि अगर रेनफॉल इतनी होगी तो डेजर्ट होगा, और अगर थोड़ी सी ज्यादा होगी तो एक बोरियल फॉरेस्ट होगा, अगर बहुत ज्यादा रेनफॉल होगी तो एक ट्रॉपिकल रेन फॉरेस्ट एग्जिस्ट करेगा। तो इसी तरह से जिस तरह से रेनफॉल डिस्ट्रीब्यूशन को लिमिट करती है, इसी तरह से अगर रेनफॉल एसिडिक हो जाए ड्यू टू ह्यूमन एक्टिविटीज, तो ये एसिडिक रेनफॉल भी लिविंग ऑर्गेनिजम्स को अफेक्ट करेगी और उनकी डिस्ट्रीब्यूशन को, उनकी अबंडेंस को लिमिट करेगी। सो एसिड रेन कैन इंक्लूड rain, snow, fog, hail, or even dust that is acidic. The principal cause of acid rain is sulfur and nitrogen compounds from human sources such as electricity generation, animal agriculture, factories, and motor vehicles. Electrical power generation using coal is among the greatest contributors to gaseous pollution responsible for acidic rain. The gases can be carried hundreds of kilometers in the atmosphere before they are converted to acids and deposited. In the past, factories had short funnels to let out smoke, but this caused many problems locally. Thus, factories now have taller smoke funnels. However, dispersal from these taller stacks causes pollutants to be carried farther, causing widespread ecological damage. So this figure, it shows how NOx and SOx, the oxides of nitrogen and oxides of sulfur, how they are converted into sulfuric acid and nitric acid, and this is the dry deposition and this is the wet deposition. This is the emission source, a factory. So environmental effects include, जब हम environmental effects की बात करते हैं तो acid rain का जो pH है वो 4.2 से 4.4 है, and at 4.2 pH all fish they die. We can see here that frogs, eggs, tadpoles, crayfish, and mayflies they die at a pH of about 5.5. Similarly, rainbow trout they begin to die at a pH of 6. Now, this is the critical pH levels for aquatic organisms. For snails, it is 6. For crayfish, it is 5.5. For salamanders, it is 5. For perch fish, it is 4.5. So, different organisms, they have different levels, pH levels, which they can tolerate, because pH is also an environmental factor. It is also a limiting factor that has both maximum and minimum levels of tolerance for organisms. Increasing amounts of acids can mobilize aluminium ions, which are normally present in an insoluble, non-toxic form of aluminum hydroxide in the soil. However, when acid deposition reaches the ground, it appears that when the soil pH dips to 5 or lower, aluminum ions are dissolved into the water and they become toxic to plants. So this diagram, it shows acid deposition effects on trees, that how hydrogen ions from an acid rain, they mobilize aluminum, and therefore a red spruce, it has now a decreased cold tolerance and increased freezing injury. So these are the acid deposition effects on trees. Okay, so